We are recording.
Okay, hello. This is a little strange for me. Hold on for a second. I'll start by saying I'm Charlie Bowman, and this is EE641, Model-Based Image and Signal Processing is the title of the course, but it used to be called Digital Image Processing too, but that was a very boring name, so we changed it to a little more interesting name. And this is a new experience for me, and just so you can see why I keep looking to my right, which I guess would be your left, okay, is that we're on TV using an entirely new system that is like this. Hold on, like this. See, here, watch. Phantasmagoric. Hold on. I feel like we should really get some out. We can do a little bit here. Image processing in action. There's an infinite number of me. That's kind of a little scary, huh? It's like a geometric series, right? But because there's a camera here that's shooting a picture of me, and then as the picture is being taken and it's being projected on the screen over here, and it's being picked up actually through, I think, a fiber optic link to Engineering Professional Education, that wonderful organization that helps the College of Engineering disseminate knowledge to the world. And so then there are about, I think, 7 people on campus who are participating in this classroom, and that's very exciting to me. I've been teaching this class for quite a few years, actually, more years than I can actually remember. But it's typically, it used to be, typically is offered every 2 years. But we're experimenting with increasing the offering frequency, and it's nice to know there's a few people in class today. The enrollment's a little bit lower, I think, this year because the classroom here is a little bit, first of all, it's off schedule, I think, so students weren't necessarily expecting it. But also, it's a little bit more of a hike for you on-campus people coming to the other side of campus. We're in sort of a new room, and this course is really 4 courses this year, not 1, not 2, not 3, but 4. But one of the 4 got canceled, so actually I'm lying a little bit. It's 3, okay? But it's ECE 641, and it's cross-listed with BME 641. But then there's also 2 online versions of it remotely that are ECE and BME, but they actually, for redundancy's sake, just remove the BME off-campus one. So there's only 1 off-campus one, but I don't think it's a problem. I'm sure you can switch those if you wanted to. So that's kind of nice. There's a lot of changes occurring this semester, okay? So this is a course which is it's an advanced course. So this is a course really at the level of PhD research. But if you're not doing a PhD, don't worry, okay? That's still, I think you'll still hopefully enjoy this course and have some support. But I think it's a little bit maybe different than some other courses you may have taken, because I think this course, my assumption is that all the students out there really just want to learn this material. They're not just coming here to punch their tickets because they want to get a job. Although that's a perfectly valid reason to go to school. I don't want to hurt your feelings or anything, okay? I mean, and there's nothing wrong with punching your ticket to get a job, and I think actually this course can help you punch your ticket to get a job. But I think my assumption here is that everybody in this class really finds this material intrinsically interesting, okay? For a variety of reasons. You know, just because it's kind of cool. I mean, I think it's kind of cool. Or you can use it in your PhD thesis research, or you think you might be able to use it in your job someday, or you just think it's kind of, interesting to learn. So the course isn't like designed around a lot of onerous tasks that have to be performed on some clockwise system, or a gigantic guillotine comes down or something. Okay, it's really, actually, basically, we only just, I mean, I'll go through some of the course structure, but we really just have a midterm and a final, and then there are homeworks that are voluntary, except for I set up a clever system which creates a sort of a social pressure that causes you to have to do them. You'll learn about that later. It's sort of a little bit evil. But I don't actually collect them, okay? Because my assumption is that people basically want to learn the material, okay? And also, it's kind of an advanced course, so my expectation is that different students will get different things out of this course. It's not going to be exactly the same experience for every student, and that's okay, okay? So some students in here may be like advanced PhD students who are already well into their thesis and are just looking for extra ideas or maybe to even review things that they feel like they already know, okay? And other people may be looking, have never seen any of this, okay? And it's totally fresh, okay? So I really try to adapt the course so that everybody can get something out of it, given what they're coming into it and what their needs are, and hopefully, but my underlying assumption, like I've already said, is that everybody really wants to learn the material. So, well, not everybody may learn precisely the same thing. Everybody will get something valuable out of it for themselves, okay? And there's even students who've taken this course more than once. Like, for instance, Ben sat in on it, right? Okay? So, he didn't really take it, but he just sat in on it. And in the past, I've had excellent students, okay? One of the best students I've ever had, who's now making at least 3 or 4 times my salary, took this course twice, okay? I mean, honest to goodness, he took it once for a grade and got an A, and then sat in the whole thing from beginning to end the second time and audited it, okay? So, like I said, there's different things that people get out of it, but my hope is that we can kind of be adaptive, okay? Now, the topic of the course, I'm going to explain in a few minutes. Okay, well, let me just give you a little bit of background, and then I'll go into a little more depth. But the basic, okay, so this course used to be like a super highly specialized course that I was like, me and a few other demented people were interested in. But really, what's going to happen, the course hasn't really changed very much, but it seems like the research community has kind of gotten really interested in this course. I wouldn't say the course has shifted to the research community, but the research community has shifted, it appears to me, to this course. And because this course is really mostly about stochastic modeling, okay, and solving inverse problems, okay? Which sounds like, oh my gosh, it sounds like really boring, right? Stochastic modeling, solving inverse problems. But it turns out a lot of really interesting problems really can be put in this framework. So this course is really about the fundamental tools. So we really don't talk that much about the specific applications in this class, although I might from time to time mention sort of application examples. But the applications are, but I really want to focus this course on sort of the underlying tools that you can apply. So we'll have a lot of lecture material, okay, and then we'll have laboratories. There's only 3 laboratories in this class, but some of the laboratories get broken down into sub-pieces. So, so maybe you might really say it's like more like 4 or 5, okay, because I have you do some of the laboratories in 2 parts. But the laboratories, the function of those is that if you actually do it on a computer, then it's easier to remember, understand what you've done, okay? Basically, it helps really integrate your understanding of the material, okay? But the labs are hopefully not too terribly much work. So the course is organized. I actually like to say that, there's been a lot of talk about, with the onset of all this new cool technology for delivery of educational material, which I just think is just cool, okay? And I'm obviously doing it here, okay? With the onset of all that, there's been a lot of discussion about new ways of teaching, right? And there's the so-called flipped classroom, okay? Has anybody heard of the flipped classroom? Okay, I won't really attempt to tell you what the flipped classroom is because I don't really understand, but it has something about flipping the classroom, okay? Okay. So, since I didn't really understand what a flipped classroom is, instead I'm using the reverse methodology in this class. I'm going to teach this using an unflipped classroom, okay? So, the theory of the unflipped classroom is this. What happened is that in the beginning of time, they had educational institutions, okay? And I guess people like Aristotle or whatever, like came in and they said, okay, go study this thing, okay? And then a little bit later they had textbooks, okay? And the students went off and learned the material, okay? So that your assignment for that period was to learn, I don't know, differential equations. So you read about and studied the differential equations, and then you came to class, and the professor, sort of discussed the broad issues, the philosophy, the good and the bad, the good, bad, and the ugly of differential equations, okay? But you came in and you actually learned it. And then we had a philosophy in the educational research types got involved, and they told us, well, what we're supposed to do is actually teach the material in class, okay? So then, okay. But my experience has been you really can't teach anything in class, okay? Because, I mean, I don't know how it is for you, but I remember when I was a student and I went to class, what would happen is I would sit very politely for the period of time and I'd pretend to listen to what the professor was saying. And I got very good at sort of nodding thoughtfully at the right moments, okay? Yeah. Oh, yeah. And then, of course, I had no idea what the professor was saying, okay? And then I went back and studied the notes and said, oh, I understand what they were saying now, okay? So that to me is the flipped classroom. So I want to unflip that. So what we're going to do is you're going to actually study the material before you get to class, okay? Okay? I know, it's a very novel concept. And then, when we get to class, I'm going to talk about it, okay? I'm not going to attempt to teach it to you because it's much too complicated and there are way too many details for me to teach to you in class, okay? So you need to actually study it in advance, and then, when you get to class, we'll talk about it. And you can ask questions about it, and I will philosophize about it, and I will make connections between different things, and draw analogies, so that you will better understand what you've already learned, okay? So I call this the unflipped class. So a key component of the unflipped class is a very new and innovative concept called the textbook, okay? So what we're going to do is I'm like attempting to write a textbook, okay? So you're going to actually read the textbook. I actually feel a little sorry for you because I wrote it, okay? So, what can I tell you? It's the best I can do, okay? You're going to read this thing that I wrote, and then when you get to class, you'll actually know it. Now, I've actually taken great pains to write this thing in a way that isn't too difficult, hopefully, to read, okay? And also, I've spent a lot of time trying to write it in a way that it's not, everything in it is as close to as I can do, okay, true, okay? So hopefully I don't have too many things in it that are false, okay? Okay. There might be some typos and things. And by the way, any feedback I could get from you, I would be like more than super duper delighted to get, okay? So if you're going to read this, and like, this would be one of those few times when you could be reading something for class, and you know when you're going, oh, this thing, God, it's really messed up. And you could actually write down, like, on there, all your nasty little comments about how frustrated you are and this part's not clear. And you can give them to me, and then I can try to make improvements, okay? But I spent a lot of time trying to write it in a way that is both clear and true. Those are kind of competing objectives, because sometimes you want to, there's a lot, the basic ideas in the class are often pretty simple once you understand them. But on the other hand, I don't want to say things that are false, okay? So I'm pretty careful to do that. And then at the end of each section, there's actually problems, right? And the problem, so this is like And what's class, okay? Because it's like how classes used to be taught. I know, it's very boring and traditional. It breaks all the rules because it just does what people did a long time ago, okay? So it just has a textbook, and at the end of each chapter, there's problems. And then you do okay, I'm asking you to do the problems, okay? And I will collect them, but I'm going to tell you right now, it's highly unlikely that I will actually. Well, it's almost certain that I won't grade them, although I won't say it's certain, because if I change my mind, I want to always reserve that possibility. I guess there's some small probability I might go through and check them all, okay? Well, that I might do, okay? Maybe I'll, check off that you tried, okay, on every problem. But even then, it's kind of unlikely I'll assign any much credit, or any credit. I don't know, okay? I'm not making anything, but let's assume that I'm not going to give any credit. Well, you're going to want to do the homework problems, because the exams are going to be composed of the homework problems. So if you don't do them, you can't do the exams. So basically, you're going to want to do all the homework problems, okay? And then we're going to have to figure out something. So I'm not going to be posting solutions, I don't think. There's a possibility I might post some solutions for some homework problems. But maybe what we'll do is I'll try to work through a couple problem questions before the exam, okay? But hopefully, also most of the problems are things that, if you understand the notes, sometimes they're actually even done in them. You just can write the answer to the homework problem down from the notes. So that's kind of how the course is structured. So there's going to be 2 exams, there are homework problems, and then the way you get, the impetus, the primary impetus for you to do the homework problems is so that you know how to solve problems in the exam, okay? And then you have to read the chapters in order to do the homework problems, okay? So let me put up sort of a syllabus for the course. I guess I can go to the document camera. I'm still going to be experimenting with this whole thing, so bear with me if what I do. Oh, I forgot to turn the document camera on. That's the problem. So it's not taking because there's no feed, probably. There we go. This is a learning experience for me too. But I think I'm very excited about the ability to teach in this class, and I'd really like to thank the biomedical engineering department for making this facility available. I mean, it's really, they've made a wonderful investment in this sort of thing, so and it's very effective. It's nice that I can kind of do this. There is a person on the other end here, a very nice guy named Joshua. You want to say hello, Joshua? He's probably walked away from the microphone. But as soon as you get to the microphone, just say hello, Joshua, okay? Okay. But there's a guy who's it's sort of like the extra member of the class who's kind of a gardening angel. Joshua, you want to say hello? Oh, he just said hi, okay? So he's sort of our electronic guardian angel, okay, to make sure where things work. Okay, let's see. Okay, oh, that's not good. What is that? Oh my gosh, that's scary. What do I do? Come on. What open? What happened? I don't know what to. Main monitor output. Why did you do that? Oh, that was really funny that did that. Auto manual? Is there anything here? Contrast. White balance. There it goes. Okay, now, I don't know why I did that actually. Okay, so here's the syllabus. Now, we'll follow this syllabus pretty closely, but at least in the beginning, I mean, this is as close as I can get. I mean, this is an advanced course, so, you know, things can drift off of the syllabus a little bit, but I think we'll stick to it pretty closely. And I've laid out the readings for each section, okay? And they correspond to the sections of the notes, and I'm going to show you in just a minute what the primary reference for everything we're going to be doing is. And then this is when the homework are due. So let's see. So in fact, there's a homework due on this week. My God, I'm a slave driver. Okay. I guess there's a homework due on this week. So, hopefully it's not too difficult. Homework 1. Okay. Okay, these are the numbered homework. And then I'll show you in just a minute how you have to index the web page to find which actual problems you have to do each homework. Okay. And then and this sort of says what the sections are. Now the first 2 weeks are going to be just, well, this first lecture is just an introduction, and then the next week and a half is probability, and we're going to have to whip through probability at lightning speed. I assume everybody, how many people here have taken ECE 600? Put up your hands high. Okay. Okay, now for the people who have not, I don't want to embarrass anybody, for the people who have not taken ECE 600, have they taken, I assume everybody here has taken some kind of probability? Okay. Yeah, okay. Is there some, okay. Yeah, you've taken probability? I mean, yeah. Is there anybody, okay, I don't want to hurt anybody's feelings or make them feel uncomfortable, and if this is the case, come out and talk to me afterwards, but is there anybody here who has not taken any probability? So you would want some probability, okay? And if you're not taking 600 now, you probably should be if you haven't taken it already, or if you haven't taken some equivalent, like STAT offers a course that's quite similar, or you may have come from another university and taken a course like 600, okay, on basic probability. If none of those are true, then you should probably be taking 600 or an equivalent to 600. So a lot of people think that the prerequisite for this course is 637, digital image processing 1, but it definitely doesn't hurt to have taken that class. But what the most important prerequisite for this course is some probability, okay? And some maturity as a graduate student. You should have, had some experience taking courses and be able to work independently, okay? So here are the various topics. Let me go through sort of a syllabus of what the course, so this is the course description. This is my phone number. These are the course hours. Okay, I have office hours by appointment. I can always, my preference is to meet with students who have questions after class, if you can stay. And if you can't, we can make time afterwards. And the reason is I think that people's questions are fresher on their minds. For the people in I know that they don't like it when I call them this, but as EPE, they don't like when I call it TV land, because it's not TV. It's web dissemination of knowledge or something, okay? But I still think of it as TV, I'm sorry. For the people in TV land, you can email me, or this is my office phone, and later on I might be able to identify some person who would provide some, what you might call TA support. We don't really have a TA for this class, but maybe I can find one of my graduate students to help me answer questions and so forth. And then, let's see, homework. Okay, so the grading is, here are some references, although these are kind of old, honestly. Yeah, actually they're quite old. But these are like really old basic references, but I probably should update that list. I have other reading lists, actually, on the notes and web page. But I have here 30% homework, 30% midterm, and 40% final. But the objective for everybody, I mean, it's sort of a balance. It's like a balance of terror, okay? Because I want to create like some terror on the part of your students, okay? I want you to be a little bit terrified because I want you to do the work, okay? Because if you don't do the work in this class, it's easy to come to class and just say, oh yeah, I see, that makes sense. So I want to strike a balance between that, but I don't want it to absorb all your time, because I know a lot of you have a lot of other things to do that are important. And but we'll work together, hopefully to achieve that goal. Okay, now, before I talk about this, I'm going to talk about the basic concepts of the course. And I don't really have great, oh, let me go to the computer just to walk through the web page, which is important for the course, and then I'm going to sort of end up with the technical content of what the course is really about. So this is a cool thing called RIA, and it's a tool basically for students to exchange information and so forth. So I have links here, and this is basically a wiki of sorts. Maybe that's an oversimplification, but in which you can go in and let me see, and basically exchange information with each other about like how to do the problem. And by the way, academic honesty for this class. I should address that issue. And for academic honesty, I should probably put on the, how do I turn off? So does the camera from the back come back on now? Rear. What am I doing? Oh, okay. Yeah, there it is. Okay. Academic honesty. This is an important topic, so I want to see you guys face to face, okay? So, okay, now. So, first of all, I'll start off by apologizing, because I know, well, okay. Okay, part of what I'm going to discuss here is important information for everybody, because it's just explaining what it is that my expectations are. And everybody my assumption really is that everybody's well-meaning and honest, okay? And they just need to know what it is that is appropriate, okay? Sadly, and I apologize for even having to bring this issue up, there are a very small number of people, but unfortunately there seems to be a small but persistent number of people who did things which are academically dishonest, okay? I'd like to say there isn't, but sadly there is. I have to say that I have some sort of bizarre, uncanny ability to be able to ferret those people out and to make their lives absolutely miserable, okay? And I've absolutely, it's been a horrific experience for some of those individuals. Okay. I mean, like, you can't believe, and I'm not allowed to tell you, okay? But if I was allowed to tell you, it would be a really good story, okay? So just don't do it. I mean, it's a crazy idea. It's just a really bad idea to do anything that's academically dishonest, okay? So there are actually, oddly enough, human beings out there who actually been in my classes who intentionally do things that are academically dishonest. It's bizarre, okay? But it's not ended very well for them, okay? Okay, now, but I think what is also happens sometimes is people are humans, right? And they get caught up into situations and they're not thinking, and at the last minute they do something under the pressure of the moment that, if they were thinking more clearly they wouldn't do. And it's sort of like there's this movie, VeggieTales. Has anybody ever watched VeggieTales? And it's the VeggieTales episode on The Big Fib, okay? Where there are various vegetables that are friends. One is I don't know. What are they?
The zucchini.
One's a zucchini, and the other one's something else, okay? And I think the zucchini tells a lie, okay? He drops his mom's plate and it breaks, okay? And then and his mom asks him, well, did you drop the plate? And he said, no, okay? But then he feels really bad at it, and it's this like circle of lies, and it gets bigger and bigger and bigger and bigger until finally he realizes he has to just, own up and say, I actually broke the plate. And then all this evil stuff sort of disappears, and it's really good. Okay, so don't let yourself get into that position. Think in advance. If for some reason, I don't think so much for this course, but if you would get like in a situation where you're way behind on the lab or something, what do? If there was some disastrous situation where there was something due the next morning and your entire performance in this class depended upon it, and you're unprepared, and you have the opportunity to do some extremely unethical thing, okay, and it's 3 in the morning and you're tired and you've been up for 3 days in a row, what do?
You sleep.
that's good. And then what do?
Try to make up.
You contact me, okay? Yeah, it's basically the same kind of thing, okay? All right, it is never worth it to do something unethical, okay? It really just isn't. Because, you know, your behavior is a matter of honor, okay? This class is not just a game, okay? Where, okay, it's just a game and we're just, you know, they didn't really mean it. No, I really mean it. Your actions in this class reflect your honor as a student to me, okay? As well as to Purdue, but especially to me. And if you should dishonor yourself by doing something like that, that would be something that could never be erased, okay? So you just never do it, okay? So you think that through now, and if you find yourself in an awkward situation as a human being, if that ever happens, you just contact me and we'll figure something out, okay? There's never any consequence that could possibly be so bad that you'd want to do that, okay? So just don't do it. Okay? Don't ever think about it. And it's good in life, actually, to think ahead to situations in complicated scenarios so you don't accidentally find yourself into a situation where you wouldn't want to be, okay? These are just good life skill issues. Okay, so, sorry, I have to do that every time because it's important. Okay, PC. Okay, now, so this is the web page. Now, the class notes. All this stuff here is fine, but you really don't need any of it, okay? The only thing you really need is this thing here. These are the draft notes, okay? So, should be coming up. Open. Okay, I'll say save. Where did it save it? Okay, so these are the notes for the class. Okay, and I'm getting used to this. Okay, so there's probably what you want to do is this is kind of going slow. What does this mean? Do you understand what this? Does anybody know how I'm supposed to answer this?
Useful.
Okay, good. Maybe. Okay, you know what? Maybe I need to use my laptop. But I've had problems with that sort of thing too. Maybe I need to practice. Okay, this is okay. What's it doing? I think they need to buy faster computers, honestly. Okay. What's it doing? Oh my God, it seems to be going nuts. Okay. Okay, it seems to be happier now. Okay, so these are over here you can see the index chapters. So the next 2 weeks we're just going to be doing the probability. Okay. And so this is, and you can see here, this is the table of contents. So we have probability, causal Gaussian models, non-causal Gaussian models, map estimation with Gaussian priors, non-Gaussian map MRF models, map estimation with non-Gaussian priors. And then the expectation maximization algorithm, and then Markov chains and hidden Markov models, and then general MRF models, and then map estimation. Okay, hold on. And then the scrolling is backwards on this computer, which is why I'm going back. And then stochastic simulation and map segmentation. Okay, so what do these things mean? Well, okay, we'll talk about that in just a minute, but you can see there is no chapter 1 basically. Chapter 1 is what I'm doing right now, so that's going to be the last thing I'm going to write. So I haven't written it. But at the end of each chapter, so for instance, chapter 2, which is the first real chapter, you see we have problems, and there's quite a few problems in chapter 2 because it's a review of all probability. So, and then the homeworks will be assigned from these problems. So now, okay, so now, this is actually, so I gave you the basic talk on academic honesty, okay? But now the question is, well, you need to know what's proper behavior, okay? So you're going to do these problems. You can work with anybody in the class. You can come and ask me, and I can tell you the answer. If we had a PA, you can ask that person. You can talk to somebody. I mean, in other words, any source of information you can find, you're welcome to get. My objective is for everybody to get every problem right, okay? So you can go on the web, okay? But I expect that you write every answer up yourself. Well, first of all, I may not even collect them, so then this all becomes moot, okay? Look, I mean, you could copy from somebody. You're not supposed to copy from somebody, okay? So you should, I mean, you can use their answer, but you have to rewrite it yourself, okay? Okay? But the objective here is for you to learn it. Why? What's the functional answer to why you need to, the short-term functional answer to why you need to know how to do these problems? I've told you a couple times already. Your first test question.
Yeah, they'll come in and test.
They're going to be on the test. I'm going to take these problems and I'm going to put them on the test, okay? I may make very minor modifications. I might shorten them or take out certain parts, okay? But pretty much I'm going to cut and paste these problems onto the exam, okay? It's a wonderful thing because it saves me a lot of time, okay? And it creates terror among the students because if they don't know how to do the problem, they can't answer the test. Okay? But you're welcome to work with anybody you want or ask me any questions, okay? Okay, so there's no secret. It's just that you need to know the answers to these problems.
Why are we not like giving the luxury of the solutions to these problems?
Because I don't have them. If I did, I could give them to you. I actually do have partial solutions to some problems. I actually have, I'll give you the gory, I'm an open book, okay? So I have those secrets. Okay. Well, I have a few secrets, but they're very limited, okay? Okay, but you see, any question you ask me, I'll answer, okay? So I had a TA trying to work out the problems for these, okay? But it didn't go well, okay? Okay. And he got some of them, but I wasn't really satisfied with all the solutions. So I'm going to have to pick and choose. There might be some. But I'm going to tell you right now, I'm not going to have answers to all the problems, okay? There's even a few of them that I don't have to do. Okay? But most of them I do.
The only concern is that if we solve the problems, then we may never know that have we solved them correctly or like.
Yeah. Well, you can show it to me, and I'll ask me, and I'll tell you.
Because now many professors like they don't like answer all of the questions. I mean, you go to the office. So if you are like willing to answer all of the questions in the office, that's fine with me.
Yeah. As a matter of fact. Let me think about this a little bit, but in general, you can show me your answers, and I'll tell you, yeah, this looks right, this doesn't look right, or this is how to do it, okay? Okay? Actually, my preference would be you actually write up your solutions, like, you know, in like electronic form, like a Word document. And then you actually share them on the wiki. Well, maybe not share them on the wiki yet. Let me think about that a little bit. But actually, that's okay. I mean, I'm not saying you can't share them on the wiki, but maybe not. Okay, let me think about that. But if you write them up in electronic form, I can actually save them for future generations. You know? Okay. So there's nothing here I'm trying to hide, okay? All I'm trying to do is, I want you to, the only objective here is for you to learn these. Now you can say, well, if I had all the solutions, I could just memorize all the solutions to every problem. Yeah, well maybe you could. I have to find that a little bit tricky. And even if we try to memorize all the solutions to every problem, even if I make extremely minor modifications, you'll have a lot of difficulty, okay? Because, you know, the material, I think, correct me if I'm wrong for others who know this material, really requires you understand the stuff, or you'll just get lost, okay? You're nodding, right, because you've seen it. I mean, students who have been exposed to this have kind of seen that you don't understand this material, you just get lost, okay? It's like, this course is about, like, if you understand it, it's easy. And if you don't understand it, it's unbelievably hard. It's like having some sort of combination lock, okay? If you know how the combination is, it's easy. If you don't know the combination, you just spend your entire life, okay? So, if you understand this concept of this class, the answers are easy. It's like a Rubik's Cube. You go, and you're the answer, okay? And if you don't understand it, you'll just get lost in a huge labyrinth of confusion, okay? So all I want you to do is be able to solve every problem, okay? And you can work together. You can use resources on the web. You can ask me, okay? That's all, okay? So it's a simple thing in that sense. It's deceptively simple. Okay, so that's how this is organized. Okay, so now I want to go through what is actually the content of the course. So we'll finish on the most important thing. Okay, so this is what we're going to do. Okay, so it's going to, well, I think I already kind of went through these a little bit. Okay, so let me explain what it is that this course is really about. What is this course really about? Okay, so what this course is really about is this. So you have, this thing's kind of, yeah, that's good. Okay, so what happens is this. In real life, you tend to have things like this. You have systems. Okay? And the systems, there's usually something that you don't know, okay, about the system. So this might be, for instance, image. Okay. When I say image, I mean it in the general sense. It could be a volume. It could be a three-dimensional image, or it could be a four-dimensional image. And you have some system. So this thing could be a CT. It could be a telescope. It could be, I don't know, a microscope. It could be all kinds. It could be a cell phone camera. It could be all kinds of things, okay? And you're trying to form an image. But so normally the conventional wisdom is that the output of an imaging system is an image, okay? Well, very often the output of an imaging system isn't an image, or it's not the same image as you're trying to form. And even if it is, it could be related to the original image in some very complicated way. Like this could be a lot of nonlinear distortions and transformations, could be a lot of noise, and you might be measuring a whole lot of stuff that to measure an image, you may measure way more than you needed, okay? And it's as if somebody sent you to the supermarket and they said, well, you know, I need dinner, and you say, well, what should I buy? And they said, I don't know. So you just went to the supermarket and you bought everything. And you brought it all home, and you sorted out what it was, and then it wasn't even like you bought. In the end, you were going to have veal parmesan, okay? But you can't buy. Well, you could buy the veal parmesan, but it was pretty bad. So instead, what you bought the veal and you bought the tomato sauce. I don't want to hurt anybody's feelings who's a vegetarian, okay? And you bought and you mixed it together. You had to do a deconvolution or a convolution and put it together, okay? So the stuff you measure out of here is not the image, okay? It's Y. So what you do here is you say, okay. So the conventional wisdom is that, well, what you would do is you would take this thing and you'd try to compute this. So this is the inverse. You just take the output of the system and you calculate the inverse, which is the thing you wanted to know. Now the problem with that approach is multifold, okay? First of all, it may be that the inverse is very complicated to compute, because the forward model for this system may be very nonlinear. It may have a lot of noise, okay? It can be a lot of distortions. I mean, in general, for any nonlinear system, it's not very easy to write down in closed form what the inverse is. And the whole concept of writing down in closed form the inverse implies that it was a deterministic relationship, and it may not be. So, if it's just like y equals a times x, well, then you would take y and divide it by a. So division is the inverse of multiplication, right? That's fine if you just have a scalar number and there's no noise. But if the things get complicated, it may not be very easy. But that's the standard way that it's been done for the last gazillion years, okay? Now, the approach in this class is very, very different. The approach in this class says this. what we're going to do is we'll have a mathematical model of the system, okay? And so if the input to the system is the image that I'm calling here is X, right? Then what we try to do is we try to fit the actual measured output to what we would get in our mathematical model if we actually had the correct image. This is like solving some sort of puzzle where you try to find the input that produces the desired output, right? Now you'd say, well, this seems like a perfectly good idea. Sadly, it doesn't work, okay? The reason it doesn't work is that it turns out that you can fit something, but your fit could be useless. So if you took high school physics and you made some sort of physics experiment, and the dots look like this. So I'm drawing a sequence of dots where the dots sort of randomly vary around a straight line. Now, in physics class, they always told you, never connect the dots up directly. Because when you do that, you get this line that goes up and down, and it's all squiggly, because you know that's not the way it should be. The way you know it should be is that what really happened is that you had noisy observations of some kind of linear relationship. So if you just connect the noisy dots, that's the wrong thing to do. Here you've over-parameterized the model. So if you overfit the data, you'll get a bad result. And if you just try to fit the data like this, it works very badly, okay? So instead what you want is you want a model. You have a prior model here. So this I call model-based imaging. There are lots of problems which fall into this category of model-based imaging. And to do model-based imaging, you need models. The models are going to be probabilities, okay? So you need to have a probability distribution. The model of the system is going to be like the conditional probability of y given x, and the model of the unknown is going to be the probability of x. So this class is going to have a huge emphasis on the development of models. So we're going to talk about, we'll first talk about models in 1D, okay, which is like autoregressive models, and then we'll talk about 2D models. Now there's two aspects of models which are really important that we're going to talk about in this class, okay? And I have a nice little table here I want to put up. Okay, this table right here. So, I'll zoom in. Okay, so we can have models which are 1D, and we can have models that are 2D. We can have models that are Gaussian, we can have models that are non-Gaussian, we can have models that are discrete, and for each of these cases we can have both causal and non-causal. We're going to cover this kind of matrix of all these options. And you say, well, who cares about this? Well, it turns out in 2D and more, the problem's much harder than in 1D. So that's why this is an image processing class and not a signal processing class, because the 2D problem is a lot harder, okay? Then it turns out that the non-Gaussian problem is harder than the Gaussian, but the Gaussian gives you the basic machinery. But the other thing is it turns out that the causal is much easier than the non-causal. The non-causal, though, becomes very important in the 2D case. So we're going to learn how to do non-Gaussian, non-causal 2D models. That's sort of like the ultimate objective of our effort, okay, in this class. In addition, we're going to need to know how to solve complicated problems. How do we solve this problem of solving this loop? Well, we're going to do it by doing optimization. That's why there's going to be a lot of material on optimization, right? And we're going to spend a lot of time on the EM algorithm. The people coming out of this class are going to understand the EM algorithm, and there are very few people who really understand the EM algorithm. Yeah, I know, I have 20 seconds, right? Is that correct, I think?
Yeah.
Okay, 15 seconds. Okay, and we're going to do hidden Markov models, we're going to do Markov random fields, okay? And then we're gonna apply them. In the end, one of the huge application domains for this is tomography. We can do emission tomography, diffusion tomography, all kinds of tomographies. But it's really just an example. It can also be used for things like